Hi, my name is Shirakyan. I'm a developer with Microsoft Robotics team. We have recently released RDS4, Robotics Developer Studio 4 Beta. It's a great platform for developing robotics applications. We've added brand new support for Kinect services, and we have released a new, very exciting, what we call a reference platform. It's essentially a hardware spec that describes what we believe is a great base for developing personal robotics applications. And here we have just an example of what an exciting personal robotics application can look like. This is a party photographer. It's a fully autonomous robot that wanders about the room, finds people on the scene, and takes their picture. It also uploads it to Flickr so that you don't have to mess with that. Anybody who has access to our free RDS4 download and Kinect and the reference platform can develop similar applications. This reference platform is also available in the simulator, which is a tool that comes with RDS4, and it lets you develop essentially robotic applications without having to have a physical robot, which is a great way of getting ramped up on robotics very quickly and not have to solder or connect things together. What I'm going to describe is this hardware and the software that makes all this possible. First, we have the Microsoft reference platform. This is one of the prototype units, one of the first examples of what we thought the reference platform should look like. It has a generic differential drive so that it can rotate in place. It has an array of infrared sensors. The final production reference platform is much neater than this. It also has sonars, which are great for detecting glass, for example. IR goes through glass, and you may run into obstacles. It is powered by Windows 7 running Microsoft Robotics Developer Studio 4 Beta. Obviously, this is where the brains are. And this is the Kinect camera. Of course, RDS4 has full support for new Kinect for Windows SDK that includes depth, video, and skeletal information, which is very useful. If you're developing mobile robotics applications, skeletal and depth are just invaluable. Your imagination is the only limiting factor as to what kind of applications you can develop. And this is just a DSLR that we trigger to take a picture, and we upload it to Flickr. That's another thing that is not part of RDS, but we thought it would be cool. The way this application works is it uses an array of infrared sensors to detect obstacles immediately in front of it. And of course, RDS4 has full support for working with different types of sensors, including infrareds. Kinect is also used to detect obstacles that are higher up, and of course to find people on the scene. All this information is fed through USB to the application that's written in the RDS4 framework. There's a massively scalable CCR and DSS framework that you can use to write parallel distributed applications that are essentially a necessity for robotics, because everything here is happening in parallel. While motor drives, we detect skeletons, and we have to process the information while we're turning. All that stuff requires a specific framework, and that's what RDS gives you. The algorithm itself is fairly simple. This is essentially a weekend project, so there are literally a few dozen lines of code that perform all the obstacle detection. Essentially, if it detects that something is in the vicinity of the infrared, it starts turning the robot. If it detects that there is a person on the scene, but it's not quite centered, it zeroes in on that person. It starts slowly turning until the person is pretty much dead in the center, and then, if necessary, it will move forward and trigger the camera. All of those devices have a USB support, and RDS has out-of-box support for a variety of sensors and peripheral devices. So let's see this in action.
Smile for the camera. Say cheese.
Hope you enjoyed this little demo. You can find out more about RDS4 on microsoft.com/robotics. You can also join our competition. Just go to roboticsathome.com. Have a good day.